Hello everybody and welcome to the webinar. My name is John Tracy and I'll be your host throughout this series of webinars. If you look up on the screen to my left, you'll see there's a counter up there. That's because we've had a few people let us know that they've had some challenges logging in, and we're just giving them a bit of time to sort out those issues so they don't miss the main presentation. So we'll be starting in a few minutes. If you want to grab a coffee, this is exactly how long you've got until we kick off the main presentation. This is an interactive webinar. Please do ask us questions. Please do let us know your thoughts. If we're too technical, we're not technical enough, please do give us some feedback throughout the webinar. We will be doing a live Q&A at the end, so some of the questions that we get asked we'll also cover at the end for the benefit of everybody. But if there's a question and you do want an answer to it, please do let us know through the chat console, and our marketing team here and some of our technical experts who are online will be here to answer those questions for you. The webinar will be available on social media afterwards, so on YouTube and all the other channels, on Facebook, Twitter, all those kind of things. And please do follow us on those channels. You can follow us on Twitter at StarleafCo. You can find us on LinkedIn, on Facebook, and all those other pages as well. And on those, we'll be giving you information about, obviously, new products that are available, new services, but also new events, new webinars, and other things that we're doing to keep you up to date. So I'm just looking at my console here. I see most everybody is online, so we'll get going. Well, welcome to the webinar, everybody. My name's John Tracy, and I'll be your host for this webinar and throughout this series. In this webinar, we're going to look at the future of video conferencing architecture. But before we can get to the future of the architecture, I think it will be helpful to sort of take a look back at the existing architecture and help understand why the existing architecture is no longer fit for purpose. So where did the existing architecture come from? Well, it came from the telephony network. And if you look at an image like this, it really explains everything you need to know about telephony. It was a series of wires with somebody in the middle, a young lady in this case, who took one wire and patched it to another wire, and the call went down those wires. So effectively, the network was nothing more than a transport for the voice. It took the voice from one end and sent it to the other end, with no processing in the middle, just connect one to another. This architecture is still in use today. The exchanges, like we see in this image here, are long gone. They're now, an exchange like this has been replaced by something you can hold in the palm of your hand. But the actual fundamentals of it are still exactly the same. So from a video conferencing point of view, this didn't really work because those single wires that were connected and the very, very low bandwidth that they provided just weren't enough to send moving images down. Then along came the digital world. The world went digital from a telephony point of view in about the 1970s with the rollout of ISDN. ISDN was a technology that allowed you to not only do voice calls, but actually use the network to transmit data from point to point. From a video conferencing point of view, that allowed a number of companies to spring up and start bringing video conferencing into the mainstream. Companies like Polycom, Tandberg, VTEL, PictureTel, all made endpoints that went into conference rooms. You added multiple ISDN lines to them, and you were able to encode video images and send them to the far end. But the network behind it was still fundamentally the same as that old telephony network. You encoded your images in the endpoint, and then you sent packets down a wire, in this case digitally, but you still sent them down a wire, and they were switched through to the other end, and the endpoint at the other end decoded the images onto the screen. And that's how it worked. And this worked for a number of years. But it meant the endpoints themselves did all the work. There was no intelligence in the network. It was nothing more than a transport mechanism. So we look at our endpoint. Our endpoint is a pretty basic device. It uses the H.323 protocol to encode video and audio to send over the ISDN network. We have a protocol for encoding video, in this case H.261. We have a protocol for encoding audio, G711 in this case, and our endpoint can now encode audio and video, send them over the ISDN network, and we're good to go. But as time went on, manufacturers started adding better protocols that were more efficient at encoding video and audio and also gave higher resolution and higher audio quality. And so our endpoints started to have to do more. So the endpoint now had to support maybe 3 video protocols and a couple of audio protocols. And then we started adding in other protocols to do things like channel bonding, allowing you to add multiple ISDN lines together to give you more bandwidth for those higher quality images. So our endpoint starts to get really quite complicated at this point. Then other manufacturers came on the scene. Now you would think, because of all these standards, that they would just interoperate with each other. But what we found is some manufacturers supported some protocols, but not others. Maybe one manufacturer supports H.263+, where another manufacturer doesn't. So there was a mismatch in the protocols that were supported, but also in the way that they were implemented. And you could never actually guarantee that an endpoint from one manufacturer would work with an endpoint from another manufacturer. So along came the internet, and with it came the H.323 protocol. Now the H.323 protocol, which we still use today, was basically an implementation of the same protocol that ran over ISDN, just over IP. In that it still just used the internet as a transport mechanism, and all of that processing was still done in the endpoint. So what we saw was a whole series of new endpoints from companies like Tandberg and Polycom and Lifesize and others start to appear. But these became ever more complicated. They had to do more and more work to give you better quality images, better quality audio, the ability to plug your PC in and share data with each other. And all of that work was still being done in the endpoint, but actually it was we reached a point where the endpoints were so complicated that we started to see interoperability issues introduced, not just between manufacturers, but between endpoints from the same manufacturer. All of these new protocols to do all sorts of different things started to appear. Different protocols for sharing data with each other, different protocols for different types of audio, for low bandwidth audio or a high bitrate audio. And we saw Microsoft introduce its platforms with slightly different versions of SIP and its content sharing protocols. We saw different encryption standards, and all of this starts to come in and get crammed into the endpoint. So for your endpoint to be able to communicate with all of these different devices, you have to stuff all of this code into them. And this made interoperability an absolute nightmare. It meant that you could not guarantee that one manufacturer's endpoints would work with another. And so the manufacturer's answer to this was, well, buy all of your endpoints from one company and we'll solve this problem. So rather than actually fix it, they actually made the problem worse. This led to a very unhappy endpoint because the endpoints reality, they're a very simple device. They should be encoding a video stream, they should be encoding an audio stream, and maybe a presentation stream. And all of this other stuff that was being forced into them to make them work with all these other manufacturers started to make them very, very unstable. So you would think the manufacturers would resolve this because they want everything to work with everything else. Well, the incompatibility started to hamper growth because people started to say, well, if I can't guarantee that I can make a video call between my company and another company, then maybe video conferencing is just used for internal communications. Therefore, we'll only put this in a couple of meeting rooms. We won't roll this out across the entire company. Now, you would think the manufacturers would want to solve this. But what they did was spent their time producing more and more infrastructure. So they produced devices that would make their systems easier to use. So things like gatekeepers to give you call routing and number plans and 4-digit dialing, and multi-point conference units to be able to do multi-party calling, and firewall traversal servers and management servers. But this just added to the problem. So what you ended up with was a whole load of endpoints that were really, really complicated, that did all of this stuff that I talked about in the previous slide, plus all of this infrastructure that was really, really complicated, hard to deploy, hard to manage. And the two together just made this an absolute nightmare for the end user. You could never be sure that if you actually called anybody, would the call go through? And people used to turn up to video meetings, 15, 20 minutes, half an hour before, to do a couple of test calls, to try and make sure there's the impact on productivity was just massive. So what did the manufacturers do? Well, they said, well, the answer is bridging. Let's put a bridge in the middle. You call into the bridge and we'll let the bridge do all that encoding for you. And we'll make sure that, we sort out all the interoperability problems in the bridge. Well, this was great. This solved the problem. But what about direct dialing? In the previous model, I used to be able to just call you. Now I have to send you an invite to a meeting and we join on a bridge in the middle. It seems like we've taken a step backwards. Imagine if we had to do that with the telephony network. Imagine if the only way I could call you from my mobile phone was to send you an invite to a meeting room, and I would dial into the meeting room and you would dial into the meeting room. Telephony would have died out years ago if that was the solution. We've got to get to a point where people are able to call each other just like we do on the telephone network. I don't worry when I call you from my Apple phone if you're on a Samsung phone, or if you're on a Google phone, or if you're on a desktop telephone. I just place the call, and it works every single time. So bridging as a solution really doesn't work when you start to roll it out in scale. If you need to have bridges spread all over the world and bridges talking to bridges and cascading to other bridges, we start to get into a situation that really doesn't scale to a global network. So you could say, well, whose job is it to fix this? Well, if you look at the market share from the manufacturers, if you're Cisco, you could say, we're 49% of the market. Interoperability is somebody else's problem because over half of the market uses our endpoints, they can all talk to each other, so everyone else needs to go and solve the interoperability problems and be interoperable with us. Well, that might be as the market is today, but anyone who's been in this market for a long time will remember it hasn't always been this way. There was a company called Picturetel who had 80% market share. Where are Picturetel today? Well, Picturetel went out of business and Polycom bought the remnants of them many years ago. But just because you're number one in a market doesn't mean you're going to be number one for the rest of time. There's already something much bigger on the horizon. That's Microsoft's Skype for Business platform. It is very likely that by the end of 2016 and into early 2017, Skype for Business will be the biggest video and UC platform on the planet, with more users than probably most of the others combined. So really, is it the market leader's job to be interoperable? It's a job that everybody needs to take seriously. Every company needs to make sure that they're interoperable. So another thing that we see is marketing departments, and sometimes with the best intentions, marketing departments make the wrong decision for the right reasons, certainly the right reasons for them. And they say things like, well, if no one can interoperate with us, we can control the user experience. We can make sure that everyone has a great time. Or they say, if no one can interoperate with us, we will we will own this market space because we will have no competition. So these kind of arguments, they're really rather old. A lot of companies have tried this over the years and haven't really been successful. Can you imagine again in the telephony world, if people tried to use these kind of excuses and say, well, we're going to build a telephony system, but it's not going to work with everybody else because then we'll control the telephony network. It doesn't work like that. People need a system where they can call anybody on any device at any time. But this idea of stuffing things into the endpoint is never going to stop. We're already seeing things like VP9, H.323, Google Duo, WebRTC, and even messaging apps like Snapchat, all starting to come out with video tools. And to make these interoperable and stuff all of that into the endpoint, we're going to end up with some very unhappy endpoints that don't interoperate well with the rest of the world. And if you can't trust the technology, people will always fall back on the older, more reliable ways of doing it. So in this case, they'll go back to audio conference calls or to traveling. Now, some people like to travel, but I don't know anyone who actually says they enjoy audio conference calls. In fact, most people do what I do, and I'm sure none of you do, is you press mute when you're on an audio conference call and you kind of do your email. And then you can always tell when somebody does that because they use a phrase and they say, I'm sorry, I didn't quite catch that. Could you repeat that? That means I wasn't paying attention, I was doing my email, but I heard my name, so could you just repeat what you said? And so conference calls get dragged out a lot longer than they need to because people aren't paying attention. It's very, very hard to not pay attention on a video call. If you don't pay attention, people know pretty quickly. So I think it's time to draw a line under that old architecture and say, enough. We need to begin again. We need to sit down and look at the architecture and say, how do we resolve this? Unfortunately, we don't have the luxury of just saying, look, just throw everything away, let's design something new from scratch, and let's build a completely new system. So how do we resolve it? Well, let's go back to that old architecture for a moment. There's something about that old architecture that we can learn from. No, it's not going back to switchboards like this. What it is the way that the telephony network works. And it is massively scalable. There are millions upon millions of handsets in the world, and every single one of them can call every single other one of them. So why don't we just adopt that architecture? We have endpoints, in this case telephones, connected to something. In this case it's a telephony switch or a PBX or whatever you want to call it. But it's that device's job to handle all the interoperability. The interoperability isn't done in the handset. All that handset needs to be able to do is communicate with the PBX. So going back to that previous diagram of stuffing all those protocols into the endpoint needs to understand one protocol. One video encoding protocol, one audio encoding protocol, and one data presentation protocol. And it will send its data up to the PBX, or to the switch as we call it, and it's that device's job to make sure that it's placing the outward call in a format that is interoperable. So it means that the devices underneath last an awful lot longer. We all know that you can take a telephone from the 1970s and you can plug it in today and it will still work. Well, if you can find the right plug and dongle and pieces of wire, but the fundamental premise is the telephone will still work. It still speaks a protocol that the PBX or the switch can understand. So this is the architecture that Starleaf uses for its network. We replace the switch with a cloud. But the endpoints underneath it only need to be able to speak one protocol. They don't need to be able to speak all the different protocols. So an endpoint running SIP speaks SIP to the cloud. An endpoint running H.323 speaks H.323 to the cloud. And an endpoint running Skype for Business speaks the Microsoft versions of those protocols to connect to the cloud as well. And the cloud takes care of all of that interoperability. So if I'm on my H.323 endpoint and I want to call a Skype for Business endpoint, I'm actually placing an H.323 call to the cloud. I'm not worrying about the fact that it's Skype for Business. The cloud understands that the person at the other end is using Skype for Business, and it will then place the outbound call for me. To do this, you need a globally deployed cloud. And this map here, this shows the locations of the points of presence within the Starleaf cloud. We have points of presence, as you can see, over most of the world. And this allows us to not only have a fully redundant architecture, but it also means that we are set up for scale. We are set up in such a way that, that calls, no matter where they're coming from in the world, are processed and moved off locally or globally as the need occurs. I love this quote. This was from Gartner, and it says, by 2020, a no cloud policy will be as foreign to people as a no internet policy is today. Have a think for a moment. Do you know any companies that have a no internet policy? I would imagine if you work in some sort of government secret service, then maybe you're not allowed to have the internet in the office. But for most of us, having internet access in the office is commonplace. So by 2020, companies that say, no, we're not using the cloud will be as rare as those that don't use the internet in their office today. So let's talk a little bit about the ever unfulfilled promise of desktop video. And we've seen for every single year in this industry, I've heard people say, this is the year of desktop video. This is the year it's really going to take off and explode. But if we think about that old architecture, the reason it hasn't taken off and exploded is because the architecture is not geared to support hundreds of thousands or even millions of clients of people on the desktop. All of that processing requirement, we had laptops that just couldn't cope with it. So we saw companies, back in the early 2000s, like Polycom's Via Video, which was a little hardware accelerated webcam. This was the year that it was going to take off, and this was going to be the device that put video on everybody's desktop. Well, that never happened. We saw Tandberg's Movie, which was probably the first, I would say, semi-successful attempt at an enterprise desktop product, sort of centrally managed and rolled out. But again, the complexity of all the infrastructure behind it and the architecture combined to sort of make this product sort of fail and die away. And Tandberg, and then later on with Cisco, had another attempt at that with its E-series endpoints, little sort of SIP-based telephones. But again, the limited interoperability didn't really work. And then as we go into 2011, we saw the sort of first cloud services starting to appear with life-size connections as part of the Logitech group, which again suffered from poor interoperability, the need for it to support multiple protocols. because the architecture that was underlying all of these products hadn't changed at all. It was still that same old architecture of just using the internet as a transport and the devices having to be able to talk directly to each other. So, as I said, what we need is a decentralized cloud architecture where you connect to the cloud, calls are processed in exactly the same way that a telephony network works. We don't think about where's my local switch, where do I connect to? You just connect to the telephony network and it just works. So, why can't we just stick a load of those enterprise grade servers that we talked about earlier in a data center, call it a cloud and be done? Have lots of Cisco VCS servers or Polycom VBPs and other devices, Pexip bridges and all these other things, put them in a data center and say, all right, this is a cloud offering and deliver that to our customers. Well, as I said, we would need to do this globally. We would need to have these spread all over the world. But these boxes just aren't designed to scale. They are enterprise-grade hardware. They're designed to go in a data center to support a single company. Even the large Cisco box, if you were to try and roll that out on the scale of the Starleaf Cloud, you would need hundreds of these boxes, and you would need ways to manage them. So enterprise hardware really doesn't cut it when you come to deploying a global platform. So what about when your vendor tells you that they don't support your endpoint anymore? The new features that you want mean you've got to upgrade your hardware to a new endpoint. Or, sorry, we just don't support that anymore. Well, the whole point of a cloud offering, as I said, is the endpoint only needs to be able to speak one protocol. The endpoint just needs to be able to connect to the cloud. When we add new functionality, we add it to the cloud. So when we add support for Skype for Business, we didn't have to go around and upgrade all of the endpoints on the cloud to be able to support Skype for Business. We add the support into the cloud. The endpoint can still talk to the cloud. The cloud can then transcode that call as necessary to Skype for Business. And it means we get a much more scalable architecture. As new things come along, whether the next big thing is Google's Duo or something from Snapchat or one of these people, we would add that support into the cloud, and all of the endpoints connected to it would just take advantage of that. So what does the cloud architecture actually bring you? Well, really low cost networking. So there is no need to install MCUs and gatekeepers and firewall traversal boxes and all of the other pieces of architecture that need to sit in your network. It also saves you an awful lot of money because you can really simplify what you're deploying into your company. You can also use your existing endpoints. If you have endpoints in your company that your users are actually comfortable using, they've spent the last 2 or 3 years using a specific remote control, sometimes just changing those endpoints out costs you a lot more money than you expect because you have to go around and retrain all these people on how to use it. So if they're comfortable with a particular endpoint, keep that endpoint. Connect that endpoint to the cloud, and that endpoint gains a whole new lease of life. And it also allows you to do so much more with so much less. You don't need to be spending money on maintenance, on existing hardware, all of that infrastructure that's costing you, hundreds of thousands of dollars per year to maintain within your infrastructure. You can decommission all of that, save yourself an awful lot of money. So as we sort of wrap this presentation up, I want you to think of one thing when you go away. The whole premise of the Starleaf Cloud is that you can call anybody on any device at any time. You do not have to worry that you might be on an old Sony endpoint and they might be on the very latest endpoint from Polycom. The call will just still connect. Those endpoints will call into the cloud using that one protocol that they support. The cloud will do all the necessary transcoding and routing, pass the call to the other side. So this brings us to the end of the presentation. Thank you very much for your time. We will take some questions now. We'll give our marketing department just a few seconds to put them up on my screen, and we'll see what we can come back to you with. Okay, so let's take some of your questions. I'm just looking down at my console. I can see we've got quite a few questions. We've probably got time to take 3 or 4. So let's kick off with, what's the difference between the Starleaf Cloud and other cloud services? Well, let me break them down into 2 categories for you. So firstly, we have what we call the conferencing services. These are services who primarily provide multi-party conferencing. as their name implies, the likes of BlueJeans and Zoom and others. Now, they provide just the conferencing part of the service. They don't provide things like firewall traversal and registration and all the other features that the Starleaf Cloud provides. So basically what they say is, we're going to provide you a conferencing platform, but it's up to you to get your traffic to us. You have to resolve the firewall traversal, you have to resolve the registration and dialing and all the other bits and pieces of how do you get to us. Now, the other category are providers such as Lifesize and Cisco. They provide services that do encompass things like registration and other features, but they're predominantly around their own endpoints. So they don't support the registration of third-party endpoints to their services. You have to use their endpoints. And so therefore, they're going back to what I said earlier, they're sort of locking you into their solution by making sure that, that you use their platform. Now, as I said earlier, remember there's the marketing departments who say, well, if everybody uses our endpoints and our platform, then we'll have much better control and we can give you a much better experience. Well, we've sort of said that's not really true. What they're doing is limiting your choice to just their endpoints. So our second question, well, how do you differ from clouds like Cisco and Lifesize? Well, as I just said, they're predominantly their clouds are their endpoints used with their cloud platform. And if you have other endpoints, then you're out of luck. You have to trade them in and use their endpoints. Also, imagine a situation where you might be using one of their platforms today, but your company goes through a merger or an acquisition and the new part of the company uses something different. You then have a difficult choice to make. Do you stay with the platform that you have today and throw it away because it doesn't support third-party endpoints, or do you, throw the whole thing away and move to another platform? Probably better to start with a platform to begin with that supports endpoints from multiple vendors, and that way you've got some flexibility and choice in the future. As your company adapts and evolves over time, your strategy around your UC and your video can adapt with it. Okay, we've got time for one more. Is it possible to just use the conferencing services with my existing endpoints? Well, yes, you can use our conferencing platform, but as I said earlier, you're going to miss out on all those other features. The registration, the dial plans, the security, the ability to provision your endpoints and have a consistent directory across them all. All of these features come as part of the Starleaf Cloud, and by just using the conferencing service, you're missing out on all of those features. Well, that's all that we've got time for today. We're going to be running these webinars on a weekly basis, so if you found this useful and you'd like to know more, then please join us in a week's time when we'll see you for the next webinar. Thank you very much for joining us. Goodbye.